So what we know about React at this stage is that it's all about developing components, and we use a syntax called JSX for declaring the UI description part of those components. This JSX syntax has to be transpiled though to plain old JavaScript, but fortunately there are tools that just do that for us in the background, and that transpiled code can then be sent down to the browser, and it can interpret the code and paint whatever is required on the screen. We know as well that a React app is comprised of a hierarchy of components. So we have the sense of parent-child relationships between components in your React app. So all that's good, but the weakness with the React apps and our components that we've been developing so far is that they are completely static. There is no ability for the user to interact with the component. And also our React apps are completely static. They don't change based on the user's interaction. What we'd like is our React app to be dynamic, to its behavior is somehow controlled by the user based on the user's interaction, typically clicking on things, selecting things, etc., etc. So in this week's lecture, we want to add that capability to our components and consequently to our apps. The slides for this week are behind this card here. So again, it's the usual layout, PowerPoint slides on the left, in a lab, which I'll come back to in a moment, and then there's an archive again this week. The lab for this week is the first in a series of 4 labs, and what we will be doing in that series is developing incrementally a fairly rich functional React app. And you will actually be submitting that React app to me as what I'm calling your lab work, which is going to be worked 40%. So it's fairly significant. Okay, so let's talk our way through the slides for this week. So as I said, we're going to dig a little bit deeper into the components aspect of React. And we're going to look at something called component state. And this is what's going to make it possible for our components to allow the user to interact with them. And the result of that interaction will usually cause the component to change what it displays on the screen. Hence, we've got a dynamic and interactive component, and hence a UI. Then we look at something called data flow patterns. There should be a space there between, oh, there is, sorry. Data flow patterns, it turns out that data can only flow in one direction in a React app. This was kind of conscious design decision that the React team made as well. And there are upsides and possibly downsides to it as well, but we'll talk about that in a while. And then I want to talk about hooks. Hooks are going to be central to everything that we do in React. I'll look at 1 or 2 hooks today, and we will look at some other hooks in subsequent lectures. Then I will talk about something called material design, which is kind of unrelated to the 2-3 previous topics now, but I was going to try and cover material design last week, but it just didn't fit in. So I've just kind of jammed it into this week's lecture at the end. You've already come across material design in the second of the labs from the previous lecture. So a component has some data associated with it, and it turns out that the data comes from 2 sources for a component. One of the sources we've already seen, which is props. We know that props is data that's passed into a component by its parent component. We know that props are immutable, and we access the props that are passed in by means of a special object that's instantiated by the runtime, which we tend to call just the props object. The second aspect of a component's data is what we call state. And state is kind of everything that props isn't. State is something that's internal to the component. It is mutable, and that's going to be extremely important because it turns out when you change a state variable's value, that will cause the React runtime to re-execute the component or re-render it, as we say. And in that re-rendering, it's quite possible that the component may do a computation, and either way, it'll change what it displays on the screen. So it's that link between state data and making a component dynamic that's central to how React actually works. And it's really important that you are comfortable understanding that interaction and that flow. So I'm saying it's internal to the component. It causes the component to re-render, hence it's mutable. Whether you're talking about state or props, the structure of your state variables or your prop variables can be whatever you want them to be. They can be primitives or objects or arrays or any kind of nesting data structure that you want to be. You don't tend to be over complicated about them though. Now, there are one or two aspects of props that I didn't touch on last week, but so we know the props are data that's passed into a component, but maybe sometimes, especially if you're using third-party components or if somebody is using your component that hasn't necessarily been involved in the implementation and design of it, it's quite possible that they may not pass in the props, or a component may not be passed in all of the props that it expects or requires. Now, rather than the component just crashing as a result of that, maybe we'd like to be able to give default values to props if that case arises. Sometimes you don't want that to happen. Sometimes props are absolutely mandatory. And if one isn't passed in, then the component should really throw an exception. But in many cases, there are sensible kind of default values. So can we programmatically express that when we design or when we implement our component? And it turns out we can. In a similar kind of vein, it may be because of the nature of JavaScript in the sense that it's a dynamically typed language, then maybe we'd like to be careful to ensure that the props that are passed into a component are of the right type. And rather than assuming that the person that's going to be using your component is careful about that, maybe the component should have some sort of type checking code built into it if possible. And it turns out it is possible. And we'll see how to do that as well. Anyway, that's the prop stuff. The central theme here, though, is all about state. So when it comes to state, we need a way to be able to initialize the value of a state variable or variables. A component may have many state variables. There needs to be a way of initializing it. There needs to be a formal way of mutating or changing the value of a state variable. Because a state variable now isn't just going to be like any ordinary JavaScript variable. We don't sort of declare using the let keyword or the const keyword. That isn't going to work. So there's a special way of declaring it, a special way of initializing it, a special way of mutating it. And as I've already said, when you mutate a state variable, that automatically causes the component to re-render or re-execute itself. Right, the kind of 101 example is what I'm going to look at here. So on the right there, I'm giving you kind of a graphical representation of this very trivial component that I have, which I'm calling the counter component. And the message I'm trying to get across here is that this component has internally, it has a state variable, which I've called count. It's going to be an integer variable. It's going to be initialized to 0. The component also expects a prop, which I've called jump, which is going to be an integer as well. And the idea is that the component is going to have a button, and every time the user clicks the button, we're going to change the value of count by the value of jump. In other words, we're kind of incrementing the counter value. And every time we change the counter value, we know now that the component is going to re-render. Now, the code for this is actually part of the basic React Lab zip that I gave you in the previous lecture. So if we go back to that, and we start up Storybook. There's the component down here. So if I just take one of them. So clicking the button is going to change this value here. And in this case, it's going to change it by this much. Okay, so let's look at the code. There is one slight kind of cosmetic error, I suppose you'd call it, in the code that I gave you. So if you open up the related stories, which is in this file here, and you should change the last line here to exceptional. Just to explain what this line is doing. When I think last week when I was with you, or in the previous lecture, when we declared a story, which this is, then the name that was given to the story is the name of the function. But if you wanted to give the story a more kind of expressive name, so that it reads better in the storybook UI, this is how you do it here. And so, okay, I'm renaming them, and I'm not really changing the name, but that's what the effect of that line is. And now you can see I've done that for all of the stories there. Now, as I said, it's only cosmetic though. So I'm just going to save that. And if we look at the component itself, now, I guess the key line in relation to state is this line here. So you declare a state variable using a special function called uState, and you can see from the top there that uState is something that we import from the React library. And the way it works is the uState function, it returns an array to you, and in that array you contain a reference to the state variables, which is the first element. You can call that variable anything you want to, but I've decided to call it count. So that's going to be a reference to my state variable. So anytime I want to manipulate it or display it or console.log it, I'll just do a reference to the count variable. The second element in the array is a function that will allow us to mutate the state variable. So that's our mutator or our setter method. So the uState function returns an array that contains these two elements in that particular order. The argument that you pass to the uState function is the initial value that you want your state variable to have, which in my case, I wanted it to be 0. So that's my declaration. The rest of the code then, this is just a little local function that I've declared, and this is the function that's going to run when I click the button. And you can see what the function is doing. It's calling the mutator or the setter method associated with my state variable. And it's passing it essentially, it's computing the new value, but it's passing the new value that I want my state variable to have. And I said in the earlier slide that when you mutate the state variable, and that's the effect of this line here, what React will do on your behalf is it will re-execute this component function all over again. The nice thing though is that when it re-executes this line all over again, it does not reset count back to 0. It gives count whatever value you expressed here. Okay, so this uState function is quite sophisticated in terms of what it does behind the scenes. We don't need to go into the detail of how it does what it does. Technically, it uses something called closures. That's closures with a J. But all we need to be aware of is what the function does first. So number one, it declares the first when your component executes for the first time, uState will declare the state variable and will return the state variable's value initialized to whatever you specified over here. On all subsequent re-executions of your component, it will return as the first argument, sorry, it'll return as the first value of the array, the new value for your state variable. And then the rest of the code, I've just got some ordinary JSX. Here's my button. I'm referencing the on-click event handler, and that's referring to my little function up here. So when I clicked the button, this function executes. The on-click event fires, and based on the code that I have here, I'm saying when that fires, this function should execute. This event handler should execute. The event handler calls the state variables mutator function that causes the state variable value to change. React responds to that change by executing your component function all over again from beginning to end. That re-execution is what we refer to as re-rendering of your component. And as I've already said, in the re-rendering, it's always going to give you the new value for your state variable. Right, that's that. Now, there's some other little bits and pieces down at the bottom here, and it's related back to props really rather than state. This is how we declare a default value for our prop. The syntax is kind of clumsy, but that's how you do it. And this is how we declare the type that the prop should be. And we're using a third-party library called the prop type library. You can see there I imported it at the top. And it's a nice kind of, it's an expressive library in the sense that it doesn't matter how complex our props would be. In this case, the prop is simple. It's just a number. So it's quite easy to declare using the prop type library that the type of thing that the jump should be is a number. But if your prop was an array of objects and the objects had a particular structure to them, then you can express that using this prop type library. So it is quite powerful. I don't actually use it a lot in the code that I gave you. In fact, I think I don't use it at all, but I'm just making you aware. In a production kind of environment, you would use this kind of type checking and default values quite a lot, actually. In the stories that I've written, well, I have the kind of normal case here, where I am actually passing a sensible value for jump. Up here, I'm not passing any value. And so because of my coding that I've just shown you there a while ago, the default value is going to be 2. So if I look at that story, see it executing, I've called the story, you can see here I've called it default. So I'm on it there actually. And it's incrementing by 2, that's the default. The normal case is where I actually explicitly set it to 3. So it's incrementing by that. The third story then is my kind of proving to you that the type checking works. You can see here I'm passing a jump value of high, which doesn't make any sense. And what happens, I wonder, when I try and click the button for that story? It's not what you'd expect. Now you might expect it to crash, but it doesn't. Now that's just a quirk of JavaScript, I suppose. It allows you, what it effectively doing is string concatenation there. So what the prop type checking, all that will do for you from a developer point of view is that it will flag a warning message in the developer tools console just to warn you that you are misusing a prop, and presumably you should go back and correct the mistake that you've got in your code. So if I open up the developer tools, and that's not the developer tools. Try that again. And I'm just going to refresh this just to clean what's on the right-hand side. You can see here there's a warning message, and this warning message is actually coming from Storybook. When it looks at my stories and it looks at the component, it sees, based on the type checking code that I have in my component, it sees that I'm trying to invoke my component with a jump that isn't an int. And so it's giving me a warning message about that. So that's what the type checking actually does. It's not so much that it will interrupt the running of your component or anything like that. It'll just give you, the developer, a warning message. As it turns out in this case, you know, the component still kind of does something, it doesn't crash, but in many cases it would crash. The final thing I want to just kind of reinforce is this idea that every time I change a state variable, I said the component function executes from beginning to end. And just by way of trying to prove that to you, you can see in my component there, I have a console.log statement. So that console.log should output every single time I click the button. And that's my way of proving that the entire component function executes from beginning to end. It's not so much that it just does this bit repeatedly, it actually re-executes the entire function. Now I'm just arbitrarily decided to output count and jump in my console.log. And so again, if I pick the kind of normal case, and I'll refresh it just to clean it up. And you'll see on the right that every time I click the button, the console.log is actually outputting. So that's my way of kind of proving that re-rendering does mean the entire component actually executes from beginning to end. So this useState is what we use to declare a state variable. I told you what it returns back to us. It's one of a number of functions that we will look at, and they're all kind of collectively referred to as hook functions. We look at another one today, and we look at some other ones later on down the line, but they're kind of central to React's kind of runtime behavior. Just a JavaScript technical thing, the syntax that we use there in relation to declaring default props and the type checking, it's strictly referred to as static function properties. In other words, this kind of syntax here, you know, is referred to, we would say that that is a static function property of my counter function, but it's a JavaScript thing rather than a React thing. Now, again, just by the way, so we know that the browser is an event-driven environment. What we mean by that is when the user interacts with the web page, the browser internally registers that reaction by creating an event object. And that event object is available to any JavaScript code that might be resident in the browser, should it want to deal with it in some way. Now, obviously, from browser to browser, the structure of these event objects are slightly different. You know, they're native to each particular browser. That's not a good thing if you want your code to run across different browsers or to run in multiple kind of platforms or multiple environments, browser environments. So what React does is it actually takes the native event object that's created by the browser and it wraps it in a generic event object, and it makes that generic event object available to our React code. The technical name that it calls that event object is a syntactic event object. We don't need to delve into it in any detail, other than just to say that React is cross-browser compliant. The other thing I'm highlighting in this slide is that the native events, the names of the various native events in browsers have been slightly changed when you use them in the context of React. So, you know, you've got on-click event, native, the on change, where they're spelt with a lowercase, all lowercase, as you can see, whereas React uses camel case for its event naming convention. That would be relevant if you had happened to do any basic event-driven programming, browser-based event-driven programming prior to coming across React, which more than likely you haven't. So just bear in mind to use the camel case style for your event names. And you saw that in my contra component. I had on-click with a capital C rather than on-click with a lowercase c. This is the native event, but this is the React event name. So this is kind of my way of representing, this is what's happening now behind the scenes. This is kind of the flow when the user clicks the button in my counter. That causes the on-click event handler to execute. That's normal kind of browser behavior. But then because my event handler changes the component state variable, this is where we move into React space. Because it changes the state variable, that causes the component function to re-execute or re-render. That's the flow that opens up a lot of avenues to us. In particular, it opens up the whole nature of dynamics in our web pages. So that's the kind of 101 on component state, and it doesn't get any more complicated than that. But of course, what happens is you might have components that have multiple state variables, and then, you know, but the principles are still the same. The next thing I want to talk about is data flow within a React app. Last week, towards the back end, I said that every React app that you ever develop is going to finish up as a hierarchy of components. You can't get away from that. So if this is kind of a generic representation of a fictitious app that we have, so I've got my hierarchy of components, and there are a number of kind of messages that I want to kind of get across now in from this slide. The first thing is I have two different types of components, and this is virtue of what we've just been talking about, and I'm using a kind of coloring scheme to distinguish one type from another. I'm talking about stateful components and stateless components. Stateful component is a component that has at least one state variable defined within it. A stateless component is a component that doesn't have any state variables in it. So it looks like this is a stateful component. These two are stateless. This is stateful, and all the others are stateless. The other thing is, number two is, what do I mean by the nature of this kind of relationship here? What I'm calling the parent-child relationship. It's got nothing to do with inheritance or anything like that. What I am representing, or what it represents, is the fact that if you looked inside this component's return statement, in other words, it's JSX, within its JSX, it is going to be referring to this component and this component. Similarly, if you looked in the JSX of this component, it would have references to this one and this one. So if you like, this component here is delegating to these two components, delegating some responsibility for generating part of what should be appearing on the screen. So that's what I mean by this parent-child relationship. And from a data flow point of view, which is kind of the title of this slide, data can only flow in a downward direction from parent to child. And we know that props are the means of transport of data. So props only go in a downward direction. This was a conscious decision made by the React team. It's called unidirectional data flow. The opposite is what's called a bidirectional data flow, or bidirectional data binding, which all of the other frameworks, single page app frameworks that existed at the time, that's the pattern that they followed. React went against that. The main reason being that they felt it's easier to debug your code if you've got a unidirectional data flow. And it's also easier to rationalize the runtime behavior of your app as a result of there being only unidirectional data flow supported. Does make the learning curve maybe slightly more demanding, the initial kind of learning curve, but the benefits are in terms of debugging and rationalizing, as I said. The next message I want to get across is, if we just take this component here, it's a stateful component, and I've just been saying if a state variable within this component changes, then this component re-renders, it re-executes. Now, a consequence of that, though, is that these two components are also going to re-render or re-execute. And because this component has children, has a child, it's going to re-render. Because this component has two children, both of those are going to re-render or re-execute. So as a result of a state change in this component, every other component is going to re-render or re-execute. It certainly sounds inefficient, but there are ways of improving on that. So maybe when this component re-renders, the prop values that are being passed down here haven't changed from the previous rendering. And so in that case, there isn't really a need for this component to re-render and any of its children either. So we can improve on that, but for now, let's not worry about it. All I'm getting across is that when a stateful component re-renders, its children also re-render. And indeed, when a stateless component re-renders, its children re-render as well. Now, we don't know what this app displays on the screen, but it could be the case that as well, that when this component re-renders, it does some sort of computation, and maybe based on that computation, it decides, I don't want this component to appear at all, to contribute anything to the UI. In other words, I want whatever this component displays on the UI and all of its children, I want that to disappear from the screen. So what we say is that this component should be detached from the DOM. And the way it achieves that is that in the JSX for this component, it might have some sort of conditional statement, which says if certain thing is true, then don't include this in my output. So as a result, this component is detached from the DOM, and its children are detached as well. Later on, maybe the user interacts with the app again. That causes this component state to change. And maybe this time, whatever computation goes on inside in this component, it might decide, I do want this component to be part of what's contributed to the screen. So this component is reattached onto the DOM, and its children are reattached onto the DOM. So while an app is running in the browser, components may be detached and reattached to the DOM at runtime based on user interaction. And that's normal kind of dynamics. The terminology we use is that components mount and unmount. So any of the components on this app may mount, well, maybe from the top one down anyway. Any of the other components may mount and unmount and remount multiple times while the app is running in the browser. And that will all be dictated by the user, the nature of the user's interaction. Okay, so we need to appreciate all of those aspects now at this stage. And I'm just kind of documenting them here. Sorry, if I just go back again. Later on, I'll explain how you get to decide what components should be stateful and which should be stateless. But in general, it tends to be the case that it's only a small number of components are stateful. The vast majority are stateless. That's the way things transpire. And that's something that we should kind of aim for as well. We don't want too many stateful components, because then there's too much dynamics going on in our app potentially. but it kind of falls out that way anyway. So in my case, 2 components are stateful and the rest are stateless. By the way, if as a result of the user's interaction, this component's state changes, it re-renders, but anything above it doesn't re-render. Its child obviously re-renders, but if this one ain't going to re-render, and none of the other components over here are going to re-render. So this slide is just kind of repeating or documenting most of what I've talked my way through there. So I think I can skip over all of this and you can read it yourselves. So that's the basics of data flow anyway, this unidirectional idea. Next, I want to talk about hooks. As it turns out, even though React has been around since 2013, hooks only came about around February of 2019, as you can see there. So if you're reading any kind of blogs about React that's kind of pre that date, then it's probably not a good idea to continue on reading, because the style of coding is going to be different from what we see. So what are React hooks? Well, number one, they're just simply functions. HOF there stands for higher order function. A higher order function is a JavaScript term. Higher order function is a function that takes another function as an argument and possibly even returns a function as a return value. So hooks are functions that are higher order in some cases. Number two, they allow us to manipulate, I'm saying, the state and life cycle of a component. We've actually seen one hook function already, which is the useState function. We would call that a hook, as I did earlier on. But these hook functions are all about manipulating a component state and manipulating a component's kind of life cycle. The third point there is really a reference back to pre-February 2019. React always had this notion of stateful components and this idea of state causing a component to re-render and all of that stuff. But the way we achieved it was by implementing our components as classes and having special, and the class would inherit from a special superclass defined by the React framework, and our component classes then would inherit certain methods and override those methods, all of that kind of object-oriented stuff. But when essentially React changed their programming model in February 2019, when they released this idea of hooks, so we no longer need to implement our components as classes. And equally, if you're reading any articles about React and you start seeing components implemented as classes, then you're probably reading something that's a bit too dated really for this module. There are a number of hook functions, and we've seen one, as I said. We'll see another one in a moment called useEffect, and there are other ones as well. All of the hook functions actually begin or are prefixed with use, and that was a decision made by React to allow linters to do some validation, basic validation of our code, so that we weren't misusing these hook functions. And I'll explain what I mean by that in a moment. So whenever you see anything that begins with use in React, it's more likely a hook that either comes with the React framework or it's defined within a third-party library. And there are lots of third-party libraries that adopted this hooks kind of idea. And we will see one or two examples down the line. Now, there are rules in terms of how you use these hooks. And I'm saying there, number one, that you can only invoke a hook function, I'm saying, from the top level within a component. In other words, you can't invoke a hook function within an if statement or inside in a for loop. That's not allowed. And the linting tools that come with the Create React app will check to see that you're not doing that. That's what I meant by the fact that there are lenters that will check to make sure that we are using our hooks properly. And really all the lenter does is, if it sees any function that is prefixed with use, then it knows it's a hook function, and then it'll see that you are not using it in this way down here. Okay, so you can only call it from the top level. We needn't get into why that's the case. They won't work properly otherwise. The second point is, I suppose that would stand the reason that you will only be calling these hook functions from React component functions. You wouldn't be calling them from ordinary custom functions of your own, but that kind of stands to reason. So this is the important point in terms of how you should use these hook functions, where you should and should not use them. So we've seen the use state, and the second most important hook is a hook called useEffect. And from its name, what the useEffect hook allows us to do is to program what I'm calling side effects from within your component code. So if a component needs to perform some sort of side effect, then we should use the useEffect hook to do that. Now, what do I mean by a side effect? A side effect is a general programming kind of concept, may have been mentioned in other programming languages that programming modules that you've come across, but a side effect is when a piece of code wants to either access or manipulate something outside of its own scope. So it's reaching outside of its scope to cause an effect outside its own domain, if you like. Now, in the context of React apps, there's one very obvious example of a side effect, and that is if a React component wants to retrieve data from a web API, it's clearly the component is reaching outside of its own scope in order to get that data. Another example would be if a component wants to interact with the browser environment itself. We would use the useEffect hook to program that in some way. The useEffect function, it takes two arguments. It takes a callback, which is a function, hence the useEffect hook is a higher order function. It takes a callback, and it takes what I'm calling a dependency array. And it's inside the callback is where you put the side effect code, if you like. And we'll see that in a while. Now, when should the useEffect call the callback or invoke the callback? And there are specific rules around this. Number one, when the component is mounted. Now, I mentioned this term mounting and unmounting and remounting there a while ago. So when a component is mounted onto the DOM, if that component has a useEffect invocation, then the callback associated with that useEffect will be invoked. Number two, every time the component re-renders, but only if, as a result of the re-rendering, one of the entries in the dependency array, so this dependency array is going to be an array of references to variables. They could be ordinary local variables, they could be state variables, they could even be props. So when a component re-renders, and if one of the entry in its dependency array has changed since the previous rendering, then in that case, the callback will be executed again. Consequently, if a component that has a useEffect hook, if that component re-renders, but nothing in its dependency array has changed since the previous re-rendering, then the callback won't be executed at all. In many cases, what you want is you want the callback associated with your useEffect just to be executed when the component is mounted and never executed again, never executed for any re-renderings. In that case, if you just give it an empty dependency array, then that will achieve that effect. And that can arise in many cases. Let's see an example. So I've got this app, and you will get the app from the archive. So if you just grab this archive on the right, download it, unzip it, import it into VS Code, and it's a simple little React app that was created using the Create React App tool. So you run npm install. So if I just grab the code. So when you unzip the archive, this is what you will get. And I've run npm install, and it is a create React app. So if I just go npm start, and so what the app does is it makes an API call, and I'll show you the API in a moment, and it grabs Maria 10 of my friends from the web API. So it's listing my 10 friends here. These are just randomly generated, obviously, names and email addresses. And I've got a little bit of filtering going on here. So if I enter something into the text box, it will filter this list based on whatever character or characters I've typed in here. So it's basic kind of filtering, as I said. So if I go W, nobody with W in their name. If I go E, okay, so that's what it does. Now, again, I've said it a couple of times and I'll say it again. I've come up with, I'm showing you here the design of this app in terms of its component structure, and you shouldn't worry about how I came up with that, but you do need to understand the design. So what I'm trying to get across here is that I've got a component called friend, and that component is going to be responsible for generating one friend in my list. I've got a component called filter friend list, and that's going to be responsible for generating the entire list of matching friends. And at the top, then I've got a component which kind of does all the rest. This component at the top displays the header, manages the text box, and it's going to be responsible for computing the matching list of friends. By matching, I mean, once I start typing something into the text box, it's going to look through my full list, find the matches, and pass the list or array of matches, pass those down to this component. And it takes care then of managing the rendering of that list using the map function, which we saw last week. From a stateful and stateless point of view, the only component that's stateful is the one on top. So I'm sticking with this kind of color scheme. And in terms of state, on the bottom left there, I'm saying that the state is comprised of two parts. One is my full list of friends, and the second part is the current contents of the text box. Okay, so that's that. We look at the code obviously in a moment, but and so it's grabbing, in my case anyway, it's grabbing my full list of friends. I'm using a web API, an open web API called the Random User API, and you can Google this, although again, it's not that important, but it's very simple. And if you send a HTTP GET request to this Random User API, so if you send a request like this, what it will do is it will return, in this case, it will randomly generate 10 user profiles and return those back to me. So I can just show you it in action. If I just grab this and stick it into a browser tab. Okay, so it actually returns JSON to me, and maybe if I just tell it, I just want one user profile. And if I just grab that, and there are lots of online tools that you can give it some JSON and it'll format it for you. This is one of them here that I picked out earlier on. So if I paste in my JSON in there and ask it to format it for me, then you can see here, this is what a user profile will look like that returns back to me. Now I'm only interested in the person's name and I use their email address as well. There's lots of other good stuff in there as well. So this random user web API, it returns an object. The object has a key called results, and the results has a value of type array, and that array contains objects corresponding to a randomly generated user profile. So that's what I'm using behind the scenes. And I guess, can I now look at the code? Yeah, let's take a quick look at some of the code and we'll come back to the slides again. So in terms of components, if I take it kind of from the bottom up, I have the friend component that expects to receive one user profile object and it generates output for that user. So that's pretty straightforward. It's a stateless component and really it doesn't have any logic in it. It just has some JSX. So that's the component that generates, if you like, just one user. Then I have the filtered friends list component that receives an array of user profiles. And you can see what I'm doing is I'm mapping over the array, generating a friend for each one. So again, very little going on there. The main one then is the component at the top of the hierarchy. That's the stateful one, and that's where all the action is really happening. So if we now look at that, two state variables. This one is going to manage the full list of friends, which admittedly never changes, but and I'm initializing it to the empty array initially. This state variable is the one that's linked to the current contents of the text box. And that state variable clearly does change every time the user types into it. Here's my use effect hook. Here's the callback. And lo and behold, in the callback, I am making a HTTP GET request using the fetch function. I presume you've seen the fetch function. Fetch is a function that's built into pretty well every browser now, which we can use to make HTTP calls. And I'm making my HTTP call to my OpenAPI, asking it for 10 friends. Eventually, that API response will come back. I'm using the promises asynchronous programming style here as opposed to async await. I know you've definitely used async await in Enterprise Web. You may have seen the promise-based programming model as well, but I'm kind of assuming that you have. Eventually, the web API is going to respond back to us, and when it does, what do? We actually call the mutator associated with one of my state variables above, which is this one here. I'm essentially taking the full array of friends that was returned back to me, and I'm mutating this state variable, storing the full list in there. As well, here I'm just computing, this is the event handler associated with the text box, And again, if the user types something into the text box, I want to change the state variable that's managing the contents of the text box, which is the first of my two state variables there. All that's going on here is this function is going to be passed the event that has been created within the browser associated with the user entering something into the text box. These were what I was talking about earlier on, the syntactic event, which is a wrapper for the native event that's created within the browser. And it's kind of boilerplate really, but all I'm doing here, you may have seen it before anyway, all I'm doing here is I'm preventing that event from affecting any other part of my app. This is very much boilerplate. I wouldn't worry about it. Here, what I'm doing is I'm extracting the contents of the text box because I need it's the contents of the text box that I'm using to change my state variable. I'm just setting it to lowercase just to make my app case insensitive. So overall, I am changing my state variable every time the user types a character into the text box. Here is where I am computing my matching list of friends. This is what I want to the subset of friends that I want to have displayed on the screen. So I'm just computing it using the ordinary map filter, sorry, the array filter function, which you would have seen before. Friends here is referring to my state variable. So I'm just doing some basic computation there. So filtered friends is going to be an array of friends, and it'll be a subset of the full list. It may be the full list if there is nothing entered into the text box. Otherwise, it's going to be a subset of it, but either way, it's going to be an array. Could be an empty array as well, because maybe there are no friends that match whatever I've typed into the text box. So that could be an empty array, but either way, it's going to be an array. And then in the body of my component, I'm using the filtered friends component, and I'm passing down the list of matching friends down to it. And of course, I've got my text box. Now, the real focus now is this use effect hook. And when does that execute? The use effect hook, we can see here is dependency array is the empty array. So we really only want this to execute when the component mounts onto the browser. And that kind of makes sense because we only want to make this API call once really when the app loads into the browser. It will never need to execute again, which is why that array is the empty array. Back to my slides. Now, something that wouldn't have been obvious from the code is that the use effect hook, it executes, I'm saying here, at the end of a component's mount process, which means that the first time I'm really only interested, I'm really only interested in discussing this component here, because that's the one that has the use effect hook, and it's the one that has all the state variables. The other ones aren't really interesting. So this is the component that I'm particularly interested in, explaining how that works in terms of its kind of life cycle. And I'm saying that the use effect runs at the end of that component's mount process. So once the component has mounted, which means it has rendered for the first time, it's after it has rendered for the first time, then the use effect callback is executed. That wouldn't have been obvious from the code. You might expect from the code, if I just flick over to the actual code, you might think that the first time this component renders, well, that line executes, then this line executes, then this executes, and so on. This executes, well, it makes this initialization, it does its computation, and then it renders, does a console.log, renders something onto the screen. You might think that's the flow, but what I'm saying to you is that this here, this callback, doesn't execute until the function has rendered for the first time. And the second bullet point I'm saying that we must actually need to be aware of that, and you must accommodate that in your implementation. It kind of means that we don't have any full list of friends available to us the first time the component renders. And we don't want that to cause our app to crash. And really the way we avoided it, in this particular case anyway, the way we avoided it is by initializing my state variable that houses the full list of friends, initializing that to an empty array. And that kind of guaranteed that at least the component won't crash. If we initialized it to null, then it would crash, because then I'd be passing null down to my filtered friends component, and it would try and map over a null construct, which it can't do. I'm kind of proving to you here the fact that the use effect callback executes at the end of the mount process for that top component. You saw in my code there that I have console.logs entered in various places just to help us. So I've got a console.log here, and I've got another console.log down here. They're the only two that we're actually interested in right now. So console.log render friends app, which is the name of my component at the top of the hierarchy. And I've got a console.log of fetch effect, meaning that the use effect hook callback is executing at this particular point. And if we look at what's happening on the browser's developer tools, the first thing that happens is my friends app component renders. I haven't got any data yet though. So that proves to me that it renders. Then the fetch callback is triggered, i.e. the point I'm making at the top of the screen, that the effect runs after the component has mounted or rendered for the first time. Now, why does this happen? This one happens because we know that inside in the callback for the use effect, it makes an API call. Eventually that responds back with my full list of friends. And we saw in the code that what I do is I change a state variable. With that, I assign that full list of friends to one of my state variables. And of course, when we change a state variable, a component re-renders. And that's why we get this console.log occurring. Next, let's supposing I type something into the text box. Typing something into the text box triggers an event. I have an event handler associated with that. In that event handler, you saw from my code that I changed my other state variable, the one that manages the contents of the text box. And it's because that state variable changed that this console.log occurs. In other words, the component re-renders again. Of course, it's now computing my matching list of friends. When my component rendered for the first time, my friends array was empty. My list of matching friends was empty. Okay, kind of normal, but well, sorry, kind of boundary case, but still the execution would be okay. However, when the component rendered on this occasion here, I now have a full list of friends. My text box is empty though. Therefore, my matching list of friends is the full list of friends. And so that would appear. When the component rendered for the third time, I now have something in my text box, and possibly anyway, the matching list of friends is going to be smaller than the full list. It computes that and it sends that updated matching list down to my filtered friends list component, which displays them. Right, so again, it's kind of important that you understand, or you can rationalize that sequence that's happening there. And in doing so, you then have an understanding of use effect and use state and how they kind of work together to manage a component's life cycle. So yeah, we must allow for, now it turns out in this case, the use effect callback makes a HTTP call. It doesn't always have to do that, but it does in this case. It makes an asynchronous call. And this kind of reinforces the earlier point that we need to be aware of that. The consequence of it in this case is that we won't have any data. We won't have a list of friends available to us for the very first rendering of our top component. But we don't want that to cause our app to kind of freeze, waiting for the data to come back. We'd like the component to render something, if only a spinner or a little message saying waiting for data. The way I took care of it was by initializing the related state variable to an empty array. And if I hadn't done that, so this is what I actually did. Okay, if instead I had done this, then it's actually going to cause my app to crash. I'm going to prove it to you. So I'll reinitialize this to null. Now, when I save it, of course, create React app is going to retranspile and push a new update down to the browser. And suddenly I've got, sorry, I need to kill that. I've got an error. Now, what's the error telling me? Cannot read property filter of null. Where is that coming from? Well, it's because for the very first rendering of this component, friends is going to be null. It's then going to try and invoke filter on a variable of type null, and that's where the error is coming from. It cannot do that. So I'll just undo that. Kind of another way of proving to yourselves that, did I save it? Another way of proving to yourself that the top component in my hierarchy renders before any data is available is if you do the following. If you access the network part of the developer tools, and you can do what's called throttling. You can kind of simulate a slow network. So if I say slow 3G, and if I do a manual refresh now of the browser, you'll see this appearing, nothing happening here, and then suddenly my full list of friends will appear. But of course, what's happening behind the scenes is that the component is rendering for the first time, it just displays these two, and then it renders again with my full list. So let's do a refresh. Okay, so that kind of proves, I hope, what I've been getting across. So let's set this back. Now, okay, I've been concentrating on the top component in my hierarchy and the various re-rendering that happens to that component. But of course, that component has a child, and that child component also has a child. So all of those other components are re-rendering as well. And I made this point earlier on. And this screenshot is kind of proving that to me. How I achieved the screenshot is, if you look at the other components, you can see I've got console.logs, which I've commented out. So you should comment them or bring them back in. And in the friend as well, I've got a console.log that I can bring back in. And if you now run the app and start entering stuff into the text box, etc., you'll see all of these console.logs appearing. And again, at the risk of overdoing it now, so we know this render, this came from the top component. The component rendered for the first time. Don't have any data yet though. However, I have an empty array of friends. The matching list of friends is computed by the top component, which is also an empty list. It passes that empty list down to my filtered friends list component. So that's why this console.log happens. This is coming from the child of the top component. And that's all that happens. Then, of course, my use effect hook callback executes. So it looks like it actually executes after the entire hierarchy has been rendered for the first time. We know that causes a state change, which is why the top component re-renders again. Now it has 10 friends, computes the matching list, which is also 10 because there's nothing on the text box. So it passes that 10 down to the filtered friends list component. And in fact, in this case, I changed the code so it only retrieved 6 friends just so that I could fit it onto the screen. And so here are my 6 friends. So the friend component is, there are 6 instances of it executing, and that's where these are coming from. I type something into the text box that causes the state change in the top component. It re-renders. The fetch callback doesn't execute at all this time because its dependency array was the empty array, so it only runs on the first mounting of the top component. I've entered something in the text box. That means this is going to compute the subset of matching friends, passes those down to the filter friends list component, and it now just generates a subset of friend components. So between here and here, some of the friend components have actually unmounted from the DOM. I type something else in the text box and so it goes on. So there's also unmounting going on, as I said, between here and here, even though it's, well, it's only evident by that fact. Here, I'm just trying to get across all that's happening behind the scenes. It's kind of what I've talked through. So everything inside the red area is what React does for us based on state change and components rendering and re-rendering, components mounting and unmounting. So, you know, I've kind of talked my way through it. So, you know, in particular, I'm talking about when the user types something in the text box, the onChange event handler executes, that causes the state change in the top component. That top component re-renders. It re-renders all its children. They re-render their children, etc., etc. So the entire component hierarchy goes through its re-rendering or re-execution process. When all of that is done, then React, here I'm saying React computes. It computes the difference between what the current state of the DOM is and what changes it needs to carry out to the DOM as a result of all the re-rendering, because some of the re-rendering may have caused certain components to change, or it may have caused certain components to be unmounted from the DOM or even remounted onto the DOM. So here it determines what changes do I need to make to the DOM to reflect what has changed as a result of the various re-rendering. It batch computes the changes that it needs to make to the DOM. It then carries out those changes to the DOM. And as we know, anytime you modify the DOM in the browser will repaint the screen. So the last three steps here are really what goes on behind the scenes in React. Indeed, all the re-rendering is kind of what goes behind the scenes as well. Pre-commit here means it hasn't committed the changes to the DOM yet, and commit obviously means it has committed them. So this is the language that you would come across if you read about the kind of internal workings of React. It's commit phase, it's pre-commit phase. The collective term for this process here is what's called reconciliation. So let's look at hooks. We'll come back to hooks. We'll come back to data flow. We really have state covered at this stage. Okay, the only thing that's going to change is that we may have, you know, a number of state variables within a component. Although we've seen that our top component has 2 state variables. Now, the next thing I want to talk about is kind of unrelated to everything above, but I just want to cover it for completeness. It's something called material design. Material UI is a third-party library for developing React apps, and we've used it in the second lab linked to the first lecture. And I just want to give you some background to it. We'll be using it throughout this module, so it's pretty important. Back in 2010, Google took it upon themselves to come up with a set of principles or guidelines or standards related to the design of user interfaces for both native apps and web apps. And what they drew from was not so much what was best practice in that world at the time. They actually turned their attention towards classic design principles. In other words, how real world textures and surfaces are represented on pen and paper, how we represent light and light reflection and shadows, etc. And from that, they came up with a kind of a vocabulary that we could apply to user interface design. But also not just those classic principles themselves, but how can those principles be enriched and enhanced through technology and indeed science. And the collective label for this set of principles is what they call material design. Material just being a metaphor in the sense that it came from real world classic design principles. So that's quite high level, but they took the set of principles, if you like, and from that they derived what they called a set of components or material components, which are really kind of building blocks. They use the word component, which is not necessarily linked to anything related to React, but it's more building blocks is how you should think of this slide. And they have 5 categories of building blocks. So this is where it becomes, as I say, linked back to user interface design. So one category of building blocks is what they labeled display building blocks. In other words, how do we structure the content of a web page? And so we use concepts like cards and grids and lists, which you're familiar with, and we'll be using those in this module via the Material UI third-party library. Navigation is obviously an important part of a web app or a native app. So there are some core components or building blocks defined by the material design document, which we can leverage. The 4th category there, obviously inputs are a very important part of any web-based app, and there are core components linked to that, and communication building blocks or components as well. So the material design system is a set of principles and a set of building blocks that allow us to realize those principles, but there is still a lot of flexibility available to the individual, and that comes in the form of theming. Google did not simply want us to copy the way they do things. Now, by theming, we mean what kind of color scheme you wish to use, what kind of typography you'd like to use. And that's all kind of a branding that you might want to associate with your website, which is unique to your website. So there is still that flexibility available to you within the overarching kind of material design principles and building blocks. Although they do recommend that in relation to color, that you should have what they categorize as a primary color scheme and secondary color scheme. Again, just to achieve consistency from page to page from a coloring point of view. And you can define what is primary and secondary for your particular application. In relation to typography, they actually defined 13 different typography styles, which really kind of fit all possible scenarios. And you should pick a subset of those and use them across your, or at least the material design system is recommending this. Pick a small subset and use that of typography styles and use them consistently across all of your pages. And we'll see that again in this module. So where Material UI comes into the picture then is Material UI is a React-based third-party library that is linked back to the material design system set of principles. And so if you did if you did complete the lab from last week, and you will see in subsequent lectures that we will be using components from this library which are linked to those building blocks that I mentioned there. So we'll have a card component, box, grid, etc., etc. So rather than us trying to design these ourselves, we can just pick them from the library and tweak them. By tweaking, I mean you may want to slightly modify the default styling associated with them. As well, the Material UI allows you to define your own theme, although I don't get into that in the labs, but you may wish to read up on it yourselves. Now, the components, the third-party components that you will use from the library all come with their own default styling. But as I mentioned there, you may wish to tweak that styling a little bit. So that means obviously CSS in the case of web apps. And what Material UI decided to do is to adopt what's called the CSS in JavaScript model for coding our CSS. And I just want to explain that because that is the only aspect that might throw you a little bit when you're using this third-party library. If I wasn't using Material UI at all, I just wanted to do my own CSS styling, then the way I would approach it is what I'm trying to show you here on the left. I would obviously code my CSS in CSS files, and then to leverage that CSS, I import the CSS in my JavaScript, which I'm showing you in the bottom here. So it's just a standard import statement. And then I use the classes that are defined in my CSS file like this in my JSX. Of course, we know that we use class name rather than class because class is now a reserved word in JavaScript and we can't use that. So the React team decided to use the attribute class name instead. But that's how I would use raw CSS in my React code if I didn't want to use a third-party library, or in particular if I didn't want to use Material UI at all. And I think I did that actually in the second lab from last week's lecture as well, albeit using the Bootstrap CSS library. In the case of Material UI, we need to use this CSS in JS approach, and this is how you do it really. And it looks a bit clumsy initially, but I guess if you just follow the basic steps, then it becomes pretty straightforward. So what you need to do is where you would normally write CSS like this over here, what you do is you write your CSS in the form of a JavaScript object notation. So So if you contrast this here with this over here, they're the exact same, except here I'm using JavaScript object notation, whereas over here, of course, I'm just using ordinary CSS rule syntax. So you code your custom CSS, and we won't have a lot of it, but you code it in the form of JavaScript objects. You pass that object to a special function called make style, and you can see I'm importing that from the Material UI library there on top. Make style returns a function. You invoke that function. Doesn't need any arguments. You can pass it an argument, which would be linked to theming, but we're not concerned with that now. You invoke that function, and it returns an object to you. And then you use that object, as I'm doing it down here, to eventually get at the piece of CSS that you have defined up here, albeit in the form of a JavaScript object. So it's a little bit long-winded, but the majority of it is boilerplate, as in this is boilerplate, how you use it is boilerplate. The CSS in JS form is custom to your particular use case. So there are the three things that you need to do. All of this code now, and so as the name suggests, my CSS is inside my JS file, as opposed to on the left, my CSS is in a separate file. I guess that's where the name comes from. And the only thing to remember as well is when you are coding your CSS in JS, then you must use camel case syntax. So for example, here it's background color written in camel case, whereas the equivalent in plain old CSS is using the hyphenated approach. If you used this, convention over here, you'd actually get an error. The Material UI library would throw you an error. So just remember that. And that's about it, really. And you've seen examples of that from the previous lab, and you'll see a lot of this in subsequent labs as well. And apart from that, really, it's just an ordinary third-party library that we'll be using to facilitate our UI design. So that's it. A lot of material cover there, admittedly, and it's always when you start adding dynamics to any coding environment, that's when things start getting a little bit tricky, and arguably things have gotten tricky as a result of introducing state and introducing hooks into the React app environment. Now, in terms of how you should approach the homework, if you like, for this lecture, I'd strongly recommend that you spend time just playing with the Filtered Friends app, download it and zip it, and make sure you're fully comfortable with the flow in that app in terms of the life cycle of components, re-rendering and all of that stuff. And then you can tackle the lab. The lab is the first in a series of 4 labs, and it's where we roll out our movies fan application. In this week's lab, there's actually no dynamics involved. It's a static web app, if you like. So you really have enough information to complete this lab without ever having looked at the whole area of state and hooks and all of that kind of stuff. So work your way through the lab, and then in subsequent weeks, we'll build on what you will have completed from the lab.